Hello everyone, myself Shivani Mahajan, PGT Physics from Khalsa College International Public School, Ranjit Avenue. Thank you so much for giving me this opportunity to deliver a lecture on the topic kinematic concepts. Under this topic, we will learn about the terms like scalar quantities, vector quantities, like distance, displacement, acceleration, speed and velocity, etc. So we will start with the first term, scalar quantities. Scalar quantities are those quantities which need only magnitude for its existence. For example, mass, temperature, etc. Like my mass is 60 kilogram. It means my body is made up of 60 kilogram matter. It needs no any explanation for its completion. Next is vector quantities. Vector quantities are those quantities which needs magnitude as well as direction for its specification. For example, force, acceleration, etc. Let's say my weight is 600 Newton. So it means my body is pulled towards the earth with the force of 600 Newton. This statement is incomplete if we don't write towards earth. Towards earth means it shows the direction. So vector quantities are those quantities which need magnitude as well as direction. Next to it we go for the terms rest and motion. Rest. An object is said to be at rest if it does not vary its position with respect to time. And if we talk about motion, an object is said to be in motion if it changes its position with respect to time. Now, motion and rest are comparative terms. With the help of an example, like a table in my living room that is at rest with respect to earth and under motion with respect to sun. Next to it we will go for the terms distance and displacement. So first term is distance. Distance is the path covered by an object in a specific time. Distance is a scalar quantity as it needs no direction for its specification. Next to it is displacement. Displacement is the straight line distance between initial and final position of the object, and displacement is a vector quantity. Now, distance is always positive, it cannot be 0, but displacement can be 0 or negative or positive. Now, next terms are speed and velocity. Speed is distance per unit time. How much distance is covered in how much time, that gives us the speed. And speed is a scalar quantity that it needs no direction. And velocity is displacement per unit time. As I already tell you about the displacement is a vector quantity. So like that, velocity is a vector quantity. Velocity is defined as displacement per unit time, or we can say rate of change of displacement is known as velocity. Mathematically, velocity is change in position divided by time, and we can find out velocity from the graph. This is the graph that shows displacement versus time graph. We can find out velocity from this graph. Next to it, average speed and average velocity. Average speed is the total distance covered per unit total time, and average velocity is the total displacement covered per unit total time. Next to it, we will discuss about the instantaneous velocity. Instantaneous velocity is the average velocity which can be taken at a short interval of time, which is very small interval of time. And with the help of a graph, this is the graph that shows the value of instantaneous velocity. We can find the instantaneous velocity from the slope of the graph distance time that is shown in this picture, distance time graph, that will give us the value of instantaneous velocity. Next to it is acceleration. It is the rate of change of velocity and the units of acceleration is meter per second square. It is a vector quantity as it needs to specify here the direction also. So, it is a vector quantity, and acceleration we can find out from the velocity time graph. Velocity time graph gives us the value of acceleration. Now, accelerations are of two types, that is positive acceleration and negative acceleration. If we talk about the positive acceleration, when velocity increases due to some force, then it is known as positive acceleration, and negative acceleration, when velocity decreases due to the force, then it is known as negative acceleration. Negative acceleration is also known as retardation. So, by giving an example, we can differentiate between positive acceleration and negative acceleration. Speeding up of a car is an example of positive acceleration, and slow down of the car is the example of negative acceleration. So, we have revised some concepts in this video, that is scalar and vector quantities means scalar is having only magnitude and vector is having directions as well as magnitude. On the other hand, we have also discussed rest and motion, that are comparative terms. One thing is at rest with respect to something and in motion with respect to the other thing. And next is distance and displacement. Distance is a scalar quantity and displacement is a vector quantity. Next to it, we have studied about the speed and velocity. Speed जो है that is distance per unit time and velocity is displacement per unit time. Both speed and velocity are having same units, that is meter per second square. And next to it, average speed and average velocity. Average speed is equal to total distance divided by total time, and average velocity is change in position divided by total time, or we can say total displacement divided by total time. Next is we have studied about the acceleration. Acceleration is the rate of change of velocity and it is a vector quantity. And at last I have told you about the positive acceleration and negative acceleration, that is when the velocity increases then it is positive acceleration and when velocity decreases it is negative acceleration. Thank you so much for watching this video. Thank you so much.